Hi. In electromagnetism, the second part we can discuss that Fleming's left hand rule. So what is Fleming's left hand rule? So in Fleming's left hand rule, it explains that whenever the left hand, middle finger, pointing finger and the thumb stretches mutually perpendicular to each other along this and this is z-axis, you can see. So along the x-axis, you see here, this is the direction of the current and this is the direction of the magnetic field and this is the direction of the force acts on a conductor. That means it explains that whenever a magnetic conductor is placed in a magnetic field whose length is L, and in this conductor the current carrying is I, you can expect the current is carrying like this one, and which is to be kept in the magnetic field which is perpendicular to the magnetic field, you can say. So the magnetic field you can expect like this. Then the force acts on that particular conductor when this is the conductor direction of the current and the magnetic field is kept like this one. So here you see, this is the direction of this one, this is, and the pointing finger magnetic field is perpendicular to that one. We cannot see that, it is shown like this, magnetic field, and along this one it is a force acts on the conductor, you can say, or else this is the magnetic field, you can say, and the force acts on the conductor might be shown like this. So if this 90 degrees is there, here is also 90 degrees, that means these three are mutually perpendicular to each other. So therefore, whenever the conductor of length L who is carrying the electric current I, it is placed perpendicular to that magnetic field, then the force acts on the conductor will be in the direction of the thumb. So it is in what? Middle finger direction. This is what? The forefinger direction. This is what? The force acts on the conductor. So it is thumb, you can say, thumb direction. It is forefinger magnetic field, middle finger is the direction of the current and the thumb is showing the direction of the force acts on the conductor, this one. So it is when these two are mutually perpendicular, then the force acts on the conductor will be in the direction of the thumb. That is explained by the Fleming's left hand rule. From this one, so this F is equal to, we can write BIL. So what is B? Magnetic field. I is a current, L is a length of the conductor. But when the conductor is placed in angle theta, when the conductor placed by theta with the magnetic field, then what happened? The theta component, normal component, because magnetic field always be perpendicular to the electric field direction. So therefore the normal component of that particular length of the conductor is nothing but L sine theta, you can write. So here by this one, F is equal to BIL sine theta, you can say. When theta is 90 degrees, you see that one, force is maximum. That is nothing but BIL, because sine 90 is nothing but 1, you can say. When theta is equal to 0, sine 0 is equal to 0, therefore force is minimum, that is nothing but 0. So when a conductor is placed parallel to the magnetic field, there is no force acts on the conductor. But when the conductor is placed perpendicular to the magnetic field, the force will be act on that conductor is maximum. Based on this Fleming's left hand rule, an electric motor works. How this force will be act on that one, we will check that one. So here in electric motor, this is the magnetic field, this is another pole, north and south we can say. So here we can take a rectangular coil which is carrying an electric current, like this you can say, like this. It is the direction of the current which is flowing in the coil, you can say. This is kept in between the two magnetic poles. So how this Fleming's left hand rule is governed, how to rotate this armature. Armature is nothing but rotating rectangular coil in between the two magnetic poles is nothing but the armature. So here now single coil armature we have taken in this one. This is, let us see, it is A, B, C and D. You see here, this north to south, these are the lines of force are flowing from north to south, you can write, of course. Now these lines of force are perpendicular to along AB and CD. Along AB and CD. But along BC and DA, the direction of the current is in the direction of the magnetic field. So what happens in the direction of the magnetic field? If the conductor is kept, there is no force acts on that one. But when the conductor is kept in perpendicular, the force will be maximum. You see here, along AB and CD, the direction of the current, along the wire is perpendicular to the field, Hence, so on AB and CD, the force acts is maximum. That is F maximum is equal to BIL along AB and CD. But the direction of the force is how? This one, according to the Fleming's left hand rule. And the direction of the current is going upwards, like this. What happened? This force will be acting along this one. This is the direction of the force, you can say. But here it is acting like this one. So the direction of the current is downwards. Therefore, the force will be along the other opposite direction, you can say, like this. This is the field direction. The force is coming out. But here it is what? The force is going that side. So therefore, force is that side. And here it is what? It is along this direction. So the force acts on along AB and CD are quite opposite. So like this. But along CD and DA, the current direction is parallel to the field. Hence, force acts on CD and DA must be 0. So therefore, this is the width in between the BC, you can say rectangular coil. It is length we have to say. It is the breadth we can say. So in this one, the one force is acting like this one. The another force is acting like this one. The two forces are acting simultaneously on the coil. One is downward, one is upward. One is inside, one is outside, like this one. And one is inside. So parallel, anti-parallel forces, two parallel forces acts on the same body in opposite direction, then it constitutes a rotation. So the torque will be act on this one. This is B. So the torque or couple, you can say, or it is couple, you can say. Couple acting on this rectangular coil, that means torque. Couple is nothing but the pair of forces. So this torque is nothing but force into, so what you can say, perpendicular distance. Perpendicular distance. Therefore, torque is equal, force is equal to what? Force is maximum, BIL. So perpendicular distance is what? Breadth in between along the BC or DA, you can say. This is a breadth, it is length, rectangular coil, you can say. Now this L and B, so torque is equal to BI, this length into breadth we can write as a area. So since it is what? Length into breadth is nothing but area, you can say. But it is one turn, it is BIA. So if number of turns are N turns are there, the maximum torque acts on the rectangular coil which placed in between the north and south, which works on the principle of the Fleming's left hand rule, and how this electric motor is works. So electric motor is what? Which converts electrical energy into mechanical energy. So that fan we can see, we input the electric energy and it constitutes the rectangular armature which rotates in between the magnetic poles. How? Because this creates a force, and this force, what kind of the pole it can be? The force of attraction or repulsion may be created. Due to that one, the armature will be rotate, and due to inertia the rotation will be continue within the this one. So because of electricity, it creates a magnetic field, and as well as that magnetic field is repulsed by this magnetic field created by this electric conductor. So this is because of the torque. So by increasing the field, or by increasing the electric current, or by increasing the area of the armature, or by increasing the number of turns in the coil, we can increase the rotation of the torque. That is nothing but RPM, you can say. RPM of the. This magnetic folds are always be in the curved shape like this one. So because it is always be, the field will be parallel to that one, thereby it can give the torque maximum. So because of curved magnetic poles which creates radial field. So this is because why magnetic poles are curved? Because they create the radial field, enable to give the maximum torque, you can say. So this is how this electric motor is working. The rotation of the armature in between the two magnetic poles, and which is the principle of electric motor, and the basic principle in the electric motor is Fleming's left hand rule. So this is simplest phenomenon, that one. Whenever an electric conductor is placed perpendicular to the magnetic field, so which stretches like this one, this is the direction of the current, this is the magnetic field, and then the force acts on the conductor must be along the thumb, you can say. It is the Fleming's left hand rule, you can say. So thank you.